t-test for correlated mean. So t-test for correlated mean has three types: single group method, method of equivalent group, and group match for mean and SD. So first we will learn it for the single group method. Why it is called single group? Because the same group are tested two times with the same test. Therefore, their mean values are correlated. How? For example, one test was administered, maybe IQ test or some achievement or interest test was administered to the one group for the first time, or after giving some training or some kind of exposure to some course or something, second time again with the same group, their scores are, they have administered a test, and on them the test will be administered, and then their scores will be find out. Now for the same group on the same test, their first time score and their second time score, and we can find out the mean value. Now these two mean value will have some discrepancy or difference. So if we want to measure whether this difference or discrepancy is significant enough to tell that there are some effect of that training, or these two times the group show some differences, significant differences, then we can calculate with the help of t-test, and that time the t-test will be for correlated mean. Okay. Now we will have the t formula for calculating mean will be remain same, that is t is equal to mean 1 minus mean 2 divided by standard error of d. Now the formula for standard error of d will be different here. That is, standard error of d is equal to square root of sigma m1 square sigma m2 square to r sigma m1 sigma m2. Here sigma m1 is standard error of mean 1 and sigma m2 is standard error of mean 2, and r is the correlation coefficient value between the scores. So these are the things here in the formula you will get. Now take an example. At the beginning of a school year, the mean score of a group of 64 children on an educational achievement test in reading was 45 and standard deviation of 6. At the end of the school year, the mean score on the equivalent form of the same test was 50 and standard deviation is 5. Now correlation between scores on the initial and final test was calculated and found to be 0.60. Has the class made significant progress in reading during the year? So you can see in the given question, the given values are initial and final. We have n, which is 64, same group, mean 45 and 50, SD, that is 6 and 5, and also the standard error of mean is also given here, that is 0.75 and 0.63, and the R value is 0.60. So when we have these values, given values, we can put it in the formula directly, because standard error of mean values are also given to us in the question. That is 0.75 square, 0.63 square minus 2 into r, that is 0.60 into 0.75 into 0.63 is equal to square root of 0.5625, 0.3969, 0.567. Is equal to square root of 0.9594 minus 0.567. It will be square root of 0.3924. This will be 0.6264. So we can round it off it to be 0.63. This is the standard error of D, or difference. So now we have the standard error of T. We can go to the formula of T. So T is here. T is equal to mean 1 minus mean 2 divided by standard error of D. So mean difference is here 30, 50 minus 45, and standard error of D is, we just calculated, 0.63. So 5 divided by 0.63, it come out to be 7.9365. So 7.94. So this is our calculated T value. So now when we have our calculated T value, we can check now the T value in the table. So what we need degrees of freedom to check the T value. Here the formula for DF will be n minus 1, because same group the test was administered 2 times, so we considered it to be a single sample. So here n is 64, 64 minus 1, so 63. Now for 63, when we check the T value in the table, we have to be careful about one thing, that is whether it is one-tail test or two-tail test. So in the question it was asked that, has the class made significant progress or gain in their result after the course, after that 1 year, their education year. So it is about a direction, whether there is a positive change or not. So it is directional test, so it will be a one-tail test. So when it is one-tail test, what we need to do, this is one-tail test. Okay, so in table D, we will check the values at 0.010 for 0.05 and at 0.20 for 0.02 for 0.01. Because it is one-tail test, so in two-tail 0.01, 0.01 in both sides. When it is one tail, at one side of the NPC curve, we consider to have all the cases. So it will be 0.02. So 0.05 at one side, both the values. So at one side it will be 0.10. So you can see in the table that there are 4 columns here. 0.10, 0.05, 0.02, 0.01. When it is one tail, we check the value not here or here. We'll check the value at 0.10 for 0.05 and 0.02 for 0.01 level of significance. So here in this case it is one tail test. So we'll check the value here in this column. So this degrees of freedom is 63. So we'll check the value at 60. It is more nearer to 60. It is 1.67, 1.67, and it is 0.02. It is 2.39. So we can say that t values at 0.02 is 2.39 and at 0.10 is 1.97. So here our obtained t value is larger than table values. Therefore, the t is significant. Because our t value is 7.94, so it is quite higher than 2.39 and 1.97. That means the group has done significant improvement from their initial test to the final test. Thank you.